अच्छा अब okay, तो मैं लिख भी देता हूँ. This is going to be A2 reaction kinetics. अच्छा now A2 reaction kinetics is about it's mostly about concentration, ठीक है. अच्छा, first thing, just a little bit tiny thing के remember के if you have a reaction, if A reacts with B, then some product C is formed. ठीक है, so some product C is formed. कोई भी reaction है, C or multiple products can be formed, right? And they might be a catalyst. ठीक है, let's call that catalyst Z. अच्छा, now when you have a reaction going on, so the speed of the reaction it depends on concentration of the particles. ठीक है, for example, A and B are reacting. So what is going to happen is if the concentration is high, you're going to have more collisions. ठीक है, so the more concentrated they are, the more क्योंकि collision से ही सारा काम चलता है ना आगे. So old bonds get broken when they collide and new bonds get formed. So it all depends on the concentrations of A and B. And sometimes it also depends on the catalyst as well. ठीक है, so what is going to happen is your rate is basically dependent on the concentrations of A. ये जो reactant one है, ठीक है, concentration of A, and it is dependent on the concentration of B. और ये मेरे ख्याल से it's a pretty obvious concept कि A की concentration, if you increase the concentration, or B's concentration, if you increase the concentration, the number of collisions between them will increase and the reaction will become faster. Vice versa, if you decrease them, then there'll be fewer collisions and it's going to be a slower reaction, right? So it makes perfect sense. ठीक है, sometimes Z भी आ जाता है, ठीक है, sometimes the catalyst is also involved, so the rate of the reaction would also depend on the catalyst and the concentration of the catalyst. Like if you don't have catalyst, if you have very little concentration of the catalyst, maybe the reaction is very slow. If you have a very high amount of catalyst added, a very large concentration, so maybe the reaction speeds up. ठीक है? So your rate of reaction, it depends on the concentration of A and concentration of B, and your rate of reaction also depends on the concentration of the catalyst. अच्छा, ये बहुत कम chance है, ठीक है, but in rare circumstances, it might also depend on the concentration of the product. ठीक है, normally no reaction, मतलब product जो मर्जी बना है, the rate of the reaction does not depend on the concentration of the product because but sometimes you have a reaction which is an autocatalytic reaction. So only in autocatalytic reactions. Autocatalytic reactions होते हैं कि as soon as the product gets formed, the product itself acts as the catalyst. But these reactions are very rare. Normally you don't have this reaction, ठीक है, you don't have autocatalytic reactions. So only in that circumstances, just an exception, the rate would also be dependent on the concentration of the product as well. But normally it's not dependent on the concentration of the product, ठीक है. So चलो first step, ठीक है, कि your rate of reaction depends on or it doesn't matter जितने मर्जी reactant है, ठीक है, it depends on concentration of A, concentration of B, and the concentration of the catalyst, ठीक है. Does that make sense? Is that clear? Humayt, clear? This team, Harun, clear?
Yes.
Yes, sir.
अच्छा, so simple concept, right? Now there's a thing, ये जो equation है ना, what I'm going to do is I'm going to pick that equation and I'm going to add top पे ना I'm going to add अच्छा z मैंने यूज कर लिया, let me pqr कर लेते हैं, ठीक है, बल्कि स्मॉल a कर लेते हैं, स्मॉल a small b and small c, ठीक है. So I've written small a, small b and small c on top of it. That's exponent, ठीक है, so that's exponent. And if I want to get rid of the proportionality sign, क्या करते हैं, you just introduce a constant, ठीक है. So I'll just add a constant k. We'll talk about the constant later on, ठीक है. Physics के अंदर, if you're doing physics, you should know कि when you get rid of proportionality, there's always a constant that's introduced. So let's call that constant the rate constant, ठीक है. But we're going to talk about the rate constant later on. अच्छा, ये जो A, B and C, ठीक है, these are known as your, I mean, these ones. I said these are referred to as the order of the reactant or order of the reaction. ठीक है, I'm going to explain each one of them one by one. अच्छा, अभी फिलहाल just keep put this in your mind that the power, what is the power, ठीक है, we'll talk about that later, but it's known as the order, ठीक है. जैसे x square है ना, तो वो जो 2 है ना, that's on top of x, that's known as order. So अच्छा, individually speaking, A is the order of A and so on, ठीक है. B is the order of your other reactant, ठीक है. तो फिर से समराइज कर रहा हूँ, ठीक है. We discussed के when you have a reaction, you have A and B reacting. The rate depends on A's concentration, B's concentration, and maybe if there's a catalyst, it depends on the concentration of the catalyst as well, if there's a catalyst. So rate depends on all three, ठीक है. That makes perfect sense. K, you just bring it in because you want to get rid of the proportionality. And then I introduced these orders, these numbers on top of the, I mean, these are your powers. Now, पहले एक formal definition. So what is, I mean, this is the formal definition. What is order of a reactant? It is literally the exponent of the concentration of a reactant in a rate equation. ठीक है, literally what I just said. ठीक है, that's what you're. So they're going to ask you what is the order? How do you define it? तो बस वो power है, ठीक है. It's the power in the, वो जो reactant की concentration थी ना, उसकी power है, ठीक है. That's it. 1 second. ठीक है. So now let me explain this. Now what we're going to talk about is अब मैं explain करूंगा, ठीक है, graphs and the order, ठीक है. So what does order really mean? Starting with, we're going to start with order 1. और किसी एक को पकड़ लेते हैं, ठीक है. I told you that your rate of the reaction depends on the concentration of A, right? So rate depends on the concentration of A. बस उसके ऊपर power है A, ठीक है, small a. So I'm going to take that power as 1. So what does that mean? That means if I said that rate depends on the concentration of A and the order is 1, that means the power is 1. So what does that mean? मतलब ये कौन सी relationship है? इसको क्या नाम दोगे? What do you call this relationship? That when I say rate depends on the concentration of A and the power is 1. मतलब इसके लिए फिजिक्स में क्या वर्ड यूज होता है? that's directly proportional.
Proportional.
ठीक है, so that's directly proportional, right? So this one just means directly proportional. So when you have order one, ठीक है, so remember it's a very basic concept, except that they're using the word order. That's the only thing that's confusing this, ठीक है. So order one basically literally means that it just means it's directly proportional. So this is direct proportionality. And what this means is that if you increase the concentration of A, the rate will increase proportionally. So for example, if you double the concentration of A, remember square brackets is concentration. That means rate would also double. And similarly, you can triple the concentration of A, the rate will also triple. If you reduce the concentration of A by half, the rate will also decrease by half, okay? So is this clear? Order one, is this clear? Okay, what is order one? Ye clear?
Yes, sir.
Yes, sir.
ठीक है, तो obvious, ठीक है, order one. There'll be two graphs which we're going to talk about. One of the graphs is Malik, so literally it's this, ठीक है, it's this graph, which is, sorry. So graph number one just represents the relationship, which is A's concentration, ठीक है, it's increasing, and over here you've got rate. So it's going to be a linear graph. It's going to be a straight line. Starting from the origin, that's it. Okay, so that's what order one relationship looks like. And normally it is order one. Okay, if you increase the concentration of something, the rate should increase, right? Then there's another graph. And this graph is about let's say and this graph looks like this. So you're doing an experiment. And if I go back to the equation, where's the equation? So you're doing an experiment. What is going to happen as the experiment goes on? A's concentration is maximum at the start. So that means the rate of the reaction, because it's directly proportional. So when you start a reaction, A's concentration is going to be the highest at the beginning at T is equal to 0. So the reaction is going to be fastest right at the beginning. Most reactions are fast at the beginning, okay? But slowly what will happen, A will start decreasing. It will get used up. And as it gets used up, the reaction will slow down because A's concentration is decreasing and the speed of the reaction will slowly slow down. Okay? Like if you pour a can of Pepsi into a glass, you see bubbles initially, lots of bubbles, but then it starts slowing down. Okay? Everything starts slowing down because the reactants, they get used up. So as your reactant gets used up, the rate of the reaction also gets slowed down. It starts slowing down. So if I plot this thing on a graph, what would the graph look like? The graph would kind of look like this. So it's going to look something like this. Okay, start when you've got A's concentration is maximum at the beginning. ठीक है, right at the beginning. अच्छा, अब फिर and this axis is time. So now what I'm going to do is I'm just going to make some marks over here. So A's concentration is maximum at the beginning. Let's say it's over here. ठीक है, what's I think this, how many boxes is this? I guess this is the, so 1, 2, 3, probably this one. So then it's going to be So this is how an order 1 graph would look like. Like if I so something similar to this. What this graph represents is that the reactant over here, your reactant, as the reaction proceeds, it starts to decrease and the reaction slows down because it's order 1. That means directly proportional. So A's concentration goes down, the reaction slows down, so it takes a longer and longer time for the reaction to finish. So it's a curve that will probably never touch. Like it's like you're pouring a can of Pepsi in a glass, right? So initially there's a lot of bubbles, then all of a sudden the reaction slows down, takes a longer time. Then you get fewer and fewer bubbles because A is getting used up. Okay. So is the shape of the graph clear? You clear? Is Emma clear? Khadija clear? Saad clear?
Yes, sir.
Yes, sir.
And then there's another concept which is related to this graph, and that's known as the half-life. Okay, the half-life is the time required for the concentration to decrease by half. Okay, so ये मैं पहले draw कर लूं. ठीक है, so I guess ठीक है, so all these points are basically half-lives, and I'm going to explain half-life 1 second. पहले मैं draw कर लूं जरा. ठीक है, so that's enough. Achha, so half-life is the time required, like if you know about radioactive decay, half-life is the time required for the concentration. In this case, the concentration of A. So reaction started, concentration of A started decreasing. Initially, it decreased very quickly. Steepness, remember, is the speed of the reaction. Steeper it is, that means the reaction is initially very, very fast. So initially, A's concentration, the reactant concentration decreased very quickly, and it became half. At this point, it's half. So that's T1, that's your first half-life. Now the reaction is slightly slower because A's concentration is lesser. The reaction has slowed down. So it's taking, I mean, the steepness is not that much anymore. But again, that's the time required for the concentration to decrease by half again. Compared to this one, again, decreasing by half. So that's this point. So this is my second half-life. अच्छा, फिर यहाँ से you're starting at this point, what's the next half-life? Time required. So the graph is less steep now because the concentration is lesser. So the reaction is slower. So the concentration decreases further by half. So that's this point, and that's your third half-life, and so on. Okay? Now the reaction is even slower. It's taking, I mean, it's less steep. So the concentration decreases by half once more, and you reach this point, and that's your fourth half-life. And so on. Okay? It's just going to continue. And it's going to form an asymptote. So what's happening is, if you understand the concept of half-life, in a first order reaction, what you have is you have constant, half-lives. ठीक है, so in this जब वो paper करोगे ना, you'll get questions. Like the question is, I mean, they're going to ask you to maybe plot a graph, and then from the graph, they'll ask you to figure out is it first order or not. Okay, so for first order, you'll just draw these lines, the one that I've drawn over here, and see if the half-life is constant. ठीक है, और उसके अंदर जो main चीज है ना, you should know how to draw these lines. So that's A's concentration, whatever mole per dm cube that is. Let's say that's 1 mole per dm cube. So this must be 0.5 mole per dm cube. This must be 0.25 mole per dm cube. This is half of that. That's 0.125 mole per dm cube. That's even half of that. But the time required would always be constant. ठीक है? तो ये clear है? ये concept clear है? Is this clear? दोनों graphs for order 1. Is this clear?
Yes, sir.
Yes.
अच्छा तो so that's order 1. ठीक है? That's it. Now we're going to move towards order 2. अच्छा, so what does इसको एक सेकंड में अच्छा now how would order 2 look like? Now when I say that a reactant concentration order is 2, that means ठीक है, same reactant. You've got a reactant, rate depends on the concentration of A. But now the relationship is not directly proportional. It's a squared relationship. That means that's order 2. Okay, that's what order 2 is. So the first graph for order 2 is going to look like this. Okay. अच्छा, पहले तो what does order 2 mean? Before making the graph. Order 2 basically means that the rate is actually too dependent on the concentration of A. Like if you make any changes to the concentration of A, there'll be a much bigger impact on the rate of the reaction. So for example, if I double the concentration of A, the rate of the reaction will become 4 times. It's a squared relationship. So if I triple the concentration of A, so the rate of the reaction will increase, but it will not increase proportionally. If I triple the concentration of A, the rate will become 9 times. And the reverse is also true. If I decrease the concentration of A, like if I make it half, then the rate will become 1/4. So it's a squared relationship. So I'm just going to write it. Okay, what does this represent? So you double A's concentration, rate becomes 4 times. You triple A's concentration, the rate becomes 9 times. You make it 1/2 A's concentration, you decrease A's concentration, the rate decreases, but by a much bigger amount, it becomes 1/4. Okay, so it's going to become half squared, and that's going to give you 1/4. So idea clear? What does order 2 mean? Is that clear?
Yes, sir.
Yes, sir.
अच्छा, अब यहाँ पे पहला वाला ग्राफ जो था ना, that was rate versus the concentration of A. Now this graph is probably going to be an exponential graph. Okay, so it's going to be an exponential graph. That's what y is equal to x squared looks like. Okay, so you keep on increasing A's concentration, the rate increases by a much bigger amount. Okay, पिछले वाले case में it was directly proportional. Like if you increase A's concentration, the rate would increase proportionally. But now it's having a much bigger impact. अच्छा, so अब इसमें ना the second graph, ठीक है, the second graph was this one. So now the second graph was, if you were to sketch or plot A's concentration with respect to time throughout a particular reaction. So how would it look like? So remember, the difference now is that as a reaction proceeds, as A's concentration decreases, remember rate will slow down by a much bigger amount. Like if you make it 1/2, if you decrease A's concentration by half, the rate will become 1/4. If it becomes 1/3, the rate will become 1/9. If it becomes a quarter, A's concentration decreases to a quarter, then the rate will become 1/16. So remember, when it's slowing down, it's going to slow down at a much faster rate. So iske andar ye hoga ke the half-life every time will double. So if you're starting over here, at the very beginning, the reaction is going to be very fast. So let's say things happen very quickly. A's concentration decreases by half in a very small amount of time. But now the rate of the reaction slows down by a much bigger amount. So the next time it takes, it requires double the time for the concentration to decrease by half. After that, it's going to take again double the time for the concentration to decrease by half once more. After that, it's going to take, because it's going to slow down by a much bigger margin. So next time it might take a much longer time for the concentration to decrease by half. So the only difference is the concentration is having a much bigger impact. It's having a much bigger impact on the rate of the reaction. So शक्ल जो है ना इसकी तकरीबन वही है, पर the order is different and the half-life, so the half-life is different. Okay, so I'm just going to mark the half-lives. Let's say that's, and then remember this is a rough plot, okay, so it'll be asked to, so every time it's just the time required is just doubling. So the third half-life, this is the fourth half-life. So each successive half-life is double the previous half-life. ठीक है, तो is this clear? What is order 2? Is this clear?
Yes, sir.
ठीक है. Taseem, is this clear? Saleh, is this clear?
Yes, sir.
Yes, sir.
ठीक है, so just basic stuff. ठीक है, it's you just have to identify what the graph looks like. ठीक है, and it's not going to be, it's just going to be a simple question, not that difficult. Achha, this is order 2. Achha, we missed out on order 0. ठीक है, we did order 1, we did order 2. Now, what would order 0 look like? Achha, remember कि you don't have, you just have to study up till order 2. Achha, so what would happen if the order is 0? ठीक है, so you have 0 order reactions. So let's say this time the rate depends on A's concentration, but the power is 0. So Mirza, what type of relationship is this? Let's see, anyone can just make a guess.
Straight line.
ठीक है, basically इसका मतलब है कि anything to the power 0 is 1. So it means no matter what the concentration of A is, the rate would remain unaffected. It's not going to change. So you add more A, you add less A, nothing happens to the rate of the reaction. And the rate remains completely unaffected. Okay, so you do have order 0 reactants as well. And later on, we'll study how order 0 happens. So in order 0, because remember, हमने उसमें पढ़ा कि whenever you increase concentration, what did we learn? We learned that the rate of the reaction increases. Okay, so that means, I mean, we studied that as a rule, right? That whenever you increase the concentration, the rate of the reaction increases. That rule is perfectly applicable to order 1 and order 2, right? Whenever you increase concentration, the rate of the reaction will increase. But order 0 does not actually follow that rule, that if you increase the A's concentration or the reactant concentration, so nothing is happening to the rate of the reaction. Okay? So it's not following that rule. But remember, that rule is still correct. I'll explain later how order 0 happens. But remember, that rule is still correct, that whenever you increase the concentration of anything, the rate should increase. Okay? Again, I'll discuss that thing later on. Okay? So abhi to iska ye graph hai ki you've got rate and you've got A's concentration. So whatever A's concentration is doesn't matter. Okay? The rate of the reaction will just be constant. Okay? So think of this reaction as you're pouring a can of Pepsi into a glass. After 1 second, the amount of bubbles that are forming, and after 20 seconds, you're still getting the same amount of bubbles in the glass. Okay? And after 2 minutes, you're still getting the same amount of reaction. That is what order 0 is. The rate of the reaction would not change. Okay? The speed of the reaction will not change. So the other graph, like if I plot A's concentration with respect to time in a particular reaction, so your reactant is getting used up, but the speed of the reaction remains unchanged. So that means it's going to be a straight line. Remember, the gradient is the rate of the reaction, right? ये जो concentration time graph है ना, इसका जो gradient है, that's your your gradient is the rate. So your reactant is getting used up, but the speed at which it's getting used up, that's constant. So it's not going to slow down. The speed at which everything is happening, it's going to just eventually you'll run out of A, and that's when the reaction stops. So that means that's what order 0 is. Constant speed of the reaction until you reach the end. That's it. तो वो coke के bubbles हैं कि you've got bubbles forming in a glass and you're getting the same amount of bubbles every second, after 20 seconds, after 1 minute, after 2 minutes. Then abruptly, the reactants get used up and the reaction stops. Okay? So you clear? Is this clear? Or what order 0 is?
Sir, can you
Yes, sir.
explain the first graph here?
ये वाला?
Yes, sir.
ये तो वो है ना कि order 0 means के एक ही concentration जो मर्जी रखो. Rate क्या आएगा? It's going to be a constant. Anything to the power 0 is 1, right? So no matter what you take as A's concentration, it does not matter. Okay? The speed of the reaction will be exactly the same. So agar A की concentration, if you keep it high, that means you're still getting the same speed. If you keep it low, you're still getting the same speed. Okay? Khadija, clear?
Yes, sir. Thank you.
So first thing, you just have to you'll be asked to plot these graphs, and by looking at these graphs, you'll be asked to figure out what the order is. And you can we'll talk about the experimental part as well. This is one way you find out the order. And I said there are some experimental issues that I'm going to discuss. One of the experimental issue is let's just talking about an experimental issue. I said the experiment, we'll do paper 5, because there's stuff related to experiments. Now remember one thing, that when you're doing an experiment, normally what you do is, whenever you do any experiment, the purpose of an experiment is that you compare two variables and you try to find a relationship between those two variables. And you try to make a graph out of those variables, right? So you can figure out how they're interlinked, right? That's the purpose of any experiment. So for example, if you want to find out the relationship between A's concentration and rate, you're going to keep on varying A's concentration. You're going to find out, you're going to plot different points. If you keep A's concentration low, the rate will come out to be less. If it's order 1, right? If you plot A's, if you take A's concentration as high, the rate will also come out to be very high as well. And you'll make a straight line and you'll make a graph. But for any graph, the variables that you're trying to investigate, one of them is going to be an independent variable and the other one is going to be a dependent variable. Independent variable is the one that you're going to set. For example, you're going to change the normally the x-axis is your independent variable. Independent variable means that you're going to change A's concentration in every experiment. And based on A's concentration, you'll get different results. Sometimes the rate will be high, sometimes the rate will be low. And so that's going to be your dependent variable. Now, the point I was trying to make was that when you are investigating two variables, you have to ensure that all other variables are constant. Any variable that is any third variable or fourth variable or fifth variable that could affect the graph, it has to be kept constant. Okay? So whenever plotting the graph, make sure that any other variable that affects, especially rate, it affects because we're investigating rate, right? So keep all other variables constant. So keep all other variables constant throughout the reaction. That affect rate. Now these variables could be temperature. You have to keep temperature constant because that's going to affect the rate. Temperature and उसके साथ और जितना भी हमने पढ़ा था, temperature, you got pressure, you got the type of catalyst that you're using, surface area of the particles. If it's a solid, you have to kind of take the same size particles, right? So you have to keep all these variables constant. And now you've got a problem, okay? The problem is you're changing A's concentration, right? Remember, आपका जो experiment था ना, in your experiment, you didn't have just one reactant. You had B as well, you had the catalyst Z as well. So you're going to keep the catalyst concentration constant as well. You have to keep B's concentration constant as well. Okay, now you have a problem, and that problem is if A's concentration decreases in the experiment, so A is decreasing, the problem here is B would also be decreasing, right? But remember, the rule is for a fair comparison, if you're trying to investigate rate and you're varying A's concentration, you have to keep the other variables constant. So the idea is, how do you keep B, the other reactant, constant throughout the experiment? Because it is also getting used up. Okay? So you have to ensure that your other reactants, their concentration remains constant throughout. As A is decreasing, B should not decrease. तो उसका solution ये है कि you add B in very large excess. Okay, this is, you're going to add B in large excess. Now, the purpose of adding B in very large excess is that if a tiny amount of B even gets used up, the change in concentration in B is almost negligible. Okay, so remember this, if you want to stop a reactant concentration from changing, right? All you have to do is you have to add it in large excess. A की concentration, if it decreases by half, there would be very little change in the concentration of B. So, and normally what you do is that if A's concentration is like 0.01 mole per dm cube, B's concentration would probably be 10, 20 times higher. For the same reason that if a tiny amount gets used up, the concentration still kind of remains constant. Okay? The idea clear है कि how do you have to keep the other reactant concentrations constant? Is this clear?
Yes, sir.
Yes, sir.
ठीक है. So experimentally remember this, कि when you're trying to investigate rate and ACE concentration, you have to keep all of the variables constant throughout the reaction. That includes temperature, pressure, catalyst, surface area, and all other reactants. And all other reactants which you're not investigating should be added in excess. So they remain almost almost constant throughout the reaction. I mean, some of it will get used up, but overall, the quantity would probably not change by much. Okay, last point clear? Is this clear?
Yes, sir.
So Khadija, ये clear है last point? Salih, Tasneem, is this clear?
Yes, sir.
Yes.
ठीक है, so just remember कि experiment में ना you investigate in two variables, every other thing has to be kept constant, and if you want to keep the concentration of every other thing constant, you just add that in large excess, ताकि अगर वो थोड़ा सा यूज अप भी हो जाए ना, कोई खास फर्क नहीं पड़ेगा उससे. ठीक है, तो चलो ठीक है, ये अपने ग्राफ्स, वी आर डन विद द फर्स्ट पार्ट. ठीक है, द फर्स्ट पार्ट इज फाइंडिंग ऑर्डर बाय जस्ट लुकिंग एट द ग्राफ. we'll now discuss other ways of finding orders. वो फिर कल करते हैं. ठीक है, चले ओके, कल कंटिन्यू करते हैं. ठीक है, अल्लाह हाफिज.
Yes, sir. Thank you. Allah Hafiz.